Okay, and a very warm welcome from DFA Media, from me, and I'm Andy Pye. I'm a consultant editor at DFA Media across a number of print and online publications. And our topic for this morning is Maintenance 4.0, that sort of mixture of Industry 4.0 techniques and maintenance procedures. So digitizing maintenance procedures, sources of data, ways to connect it, how to collect it, how to analyze it, all of those sorts of things are the topics that we'll be covering. I expect everyone is familiar with how Zoom works by now, but in case you're not, we are in listen-only mode, and that means that the way you communicate with our panelists is via chat or Q&A. So you can put comments and questions in chat and Q&A. We will do the same. So as topics come up, we may put some references in there, and we look forward to an interactive presentation, and we will be dictated by the questions that you ask. So anything you want to put into chat, we'll do our very best to answer, or at least to note for future reference. We sometimes have so many questions we can't cover them in the 75 minutes allocated. Right, I have four excellent panelists this morning, but before I get on to them, I'm going to say that we have unusually three more DFA Media people. We have Andy Wiley in the background. He's my co-host, so he will take over if we have any problems with communications or anything like that. Tony Sachs, who's editor of Drives and Controls, he's very much in the background, and he's helping me manage the chat and Q&A so that we get the right questions at the right time. And also Aaron Blutstein is with me today. He's the editor of Smart Machines and Factories, and he has specialist knowledge of maintenance 4.0, Industry 4.0. So he will be online and chatting and intervening as I do during the event. So I will quickly list our speakers, and then I'll go round in reverse order so that they can introduce themselves a little bit, and then we'll go into our four sessions. Just quickly, I'll tell you what they are. We're going to start with what we call maintenance industry megatrends. That will be led by Pete Sopcich of Analog Devices, and he'll be talking about the key trends that are happening in the maintenance industry. And then that should go smoothly into a session on factors accelerating the adoption of AI and industrial automation in maintenance. And that will be led by Michael Lefevre from Redline Controls. Our third session will be collating data from multiple sources, which will be led by Chris Hallam of UE Systems. And last but very much not least, the positive end, which will be some easy wins in Maintenance 4.0, led by Daniel Fern of Ixon. In all cases, all of our panelists will chip in as appropriate, because it's intended to be a panel discussion rather than a lecture, as many webinars are. So in reverse order, I will pass to Daniel just to quickly introduce himself.
Good morning, everyone from the Netherlands. I'm Daniel Fern from Ixon Cloud, and we're a company that work with OEM machine builders generally, providing remote communications, data analytics, etc. Yeah, so good morning, and yeah, from a very, very wet and windy Netherlands.
Thank you, Daniel. It's certainly quite an international panel as well, because Pete will be he's logging in fact from Boston, so it's halfway in the night for him, but we'll come back to him in a moment. Next is Chris Hallam, who's very much in England, I believe.
Yes, good morning from dry England right now. My name's Chris Hallam from UE Systems. We are specialist manufacturers of ultrasound technology for condition monitoring purposes, supplying that to industries globally. So, yep, looking forward to this panel.
Lovely. And Michael, whereabouts are you this morning? You're from Redline Controls, of course.
Yeah, I'm from Redline Control and from France, and here it's wet. It's like not only in UK apparently it's dry here. So we are, for us, as Reliant Control, we are expert in communication, industrial communication, and data logging, data monitoring, and instrumentation also. It's everything around collecting data and sharing data.
Lovely. Which leads us to the United States and Pete from Analog Devices.
Yeah, good morning, everyone. My name is Pete Sobczak. I'm from the Boston area, as Andy mentioned earlier, and I'm the marketing manager for AutoSense business unit at Analog Devices. So we manage a team that's focused more on providing analytics that complement a lot of the measurement technologies that Analog Devices is traditionally providing to a pretty broad range of customers across, obviously, the industrial automation space, but also aerospace, communications, and other critical industries. So yeah, it's a pleasure to be here, pleasure to be on the panel with the team. And I guess while we're on the weather kick, I would say we're soggy here, but it's too dark to really tell what kind of day this is going to be. So figure we throw that out there while we're on it. So thank you.
Okay, well, at least you're on the right side of the States with all those heat domes that you're suffering on the western side. Let's hope that dissipates soon. Okay, Pete, well, do you want to kick off then with the an analysis of where you see the mega trends of the maintenance industry going? Yeah,
absolutely. So, and certainly expect the team here to chime in on some of this as well. But yeah, so we've been focused in the industrial automation space for some time on a pretty broad range of technologies, and I would say in having the opportunity to engage a pretty broad set of customers, we've seen a number of trends that are continuing to help accelerate the need for new ways of performing maintenance, new ways of bringing technologies to the market, and this is changing the way that we look at our traditional way of doing business. It's changing the way that the customers are focusing on how they can do business, how they deliver goods to their companies, and how they make sure that everything's operating effectively. So there's a tremendous impact, and then you throw some trends in the industry on top of that, such as skills, retiring workforces, the obvious COVID impact that it's had, and that's creating quite an opportunity, and positive or negative, depending on how you want to look at it. So I think it's important that we kind of lay all those out there and understand, where we're heading, why we're heading in that direction, and then how we can, use that as an opportunity for us and our different technologies to help improve our customers' capabilities. So I'll start with a little bit of background on the technology. That's one where we've been focused on for some time, providing measurement technologies to customers that allow the measurement of critical machines, critical sensing inputs, and using that data to create insights into the equipment during its operation. So being able to sense, interpret, convert that data into digital data, and then take that information and feed that back into systems. We see a tremendous opportunity here in the industrial automation space, and even specific to maintenance. And that's the fact that the technologies have improved significantly enough to enable new ways of collecting data, to improve the quality of the data that's being collected, and to help centralize that data in a way that makes it more effective and easier to use. So that's an obvious one that we continue to drive in the industrial space as a tremendous opportunity to instrument all the machines, all the equipment within a facility, and understand not only what that machine is doing, but how that machine is interacting within the rest of the environment that it resides in. And that's critical because you want to extract as much benefit from these machines as possible. So having that visibility into all the equipment in sync provides that type of insight. So that's one big opportunity here that we see in terms of the technologies, being available today. I would say, there's another obvious one with the COVID impact. COVID, has created a significant impact on everyone's lives, across different ways. Within the space and specific to the discussion today, the opportunity that we see here is that it's really accelerated the amount of adoption here for new ways of performing maintenance, new ways of automating a lot of the capabilities in the industrial environment, because it's created the limited access that we have to these facilities by not being able to have people on site. So not only is it difficult for us to access our own facilities, but to allow third parties and other service providers to get access to it, that's an increased challenge too as well. So, the need to have visibility into the operations of these various assets, the various production environments, that's been extremely impactful in how that's being delivered today and how that's being adopted by various customers. So I would say that's a positive that's come out of this COVID impact. And I think that we're looking at ways to help speed that up, but also make it more complementary. So it's not necessarily replacing a lot of the capabilities that we have today within these manufacturing environments, but it's helping us do those jobs better and more efficiently. And so that's it's a very much everyday part of our discussions and how we can help move that forward. And then I would say on top of all that, we've had for some time this skills gap that's starting to grow. We have an aging workforce. You see a tremendous amount of folks starting to retire. Maybe COVID has helped to accelerate some of that as well. But with that kind of changing or transition into this new world, a lot of the expertise that's been accumulated over the years is now leaving. So there's an opportunity there of how do we capture that expertise? How do we make sure that doesn't just dissipate and go away? Because there's decades of experience that have been accumulated in servicing machines and performing maintenance and automation or just understanding the operations of the environment. And so there's a tremendous need there to capture that expertise and take advantage of it and scale it so that it's not limited to a subset of folks that are just going to retire and leave and take that with them. So there's certainly an impact there on how we look at maintenance, how we look at the operations and management of these various manufacturing environments. So those are three of the key ones. I would say on top of all that, when you step back and you think about, how are we going to take advantage of this era of significant change? There's all these digital solutions. There's new solutions coming on the market, continuously. They're complicated. They're difficult to use in some cases. Which ones are best for our environment, our application? Those are important areas that we need to help our customers address, because without that, it's going to be difficult for some of them to make the decisions that are best suited for their their operations or their needs. So I would say that when you look at these technologies, the ease of use, the scalability, the value, the insights that it's bringing to customers is absolutely critical. And if we can help our customers, understand why those areas are extremely important, show them that these technologies are easy to use and show them that there's tremendous value behind it, that will also help to improve the adoption and acceleration of a lot of these technologies as well. So and these are not just about, you know, introducing new technologies to the space, you know, but it's also changing the way that we do business and deliver services. So I would say that there's an obvious number of forces acting here, you know, and I think it's really finding that right balance and making sure that we're addressing them, helping our customers, you know, understand what they need, you know, and what solutions are going to help them, and then helping them move forward in this new world we're living in.
Excellent, Pete. Thanks very much. That's a really good introduction, and it's covered off quite a lot of the major things that we'll be talking about during the next hour or so. I hadn't realised until just recently, but of course we do have 4 different nationalities on the call in our panelists today, which I perhaps might have picked up a little earlier, but I didn't. And one of the interesting things is, you know, you're mentioning the issue of skills and retirement of engineers. Is that an international problem? I mean, it's certainly a massive problem in the UK, and I'll ask Chris in a minute just to comment on that. But you're obviously suffering exactly the same problems in the US.
Yeah, we see it here. There's a significant, you know, baby boomer population that's right on the cusp. So yeah, it's consistent.
Can I ask a question?
Yes.
How can we actually ensure that operational and maintenance teams are actually trained to read predictive insights? Because at the moment, you know, they could actually be leapfrogging that whole process from going from absolutely no experience to being able to have to read data analytics and various other information.
Yeah, and I guess, Aaron, is that directed at me, I take it?
Yeah, sorry.
Yeah, we'll start with you, then you can have a cup of coffee and we'll get everybody else to comment.
Yeah, so just to make sure I've captured that, how are we making sure that these maintenance teams are trained and able to read those insights, correct?
Yeah.
Yeah, there's certainly a need here for educating and training, you know, the teams that are using these new technologies. I would say that that probably, you know, ties back into, you know, ease of use. You know, how do we make these as easy to use as possible, so that these solutions, you know, don't just provide data that they have to figure out how to interpret, but they provide insights that they can use to help them do their jobs more efficiently. And the example I would use here is for a lot of the predictive maintenance technologies that we've seen in years past, you know, are very good at providing, you know, say vibration data or other insights into a particular asset. And then you have to have an expert do, you know, the analysis on that data in order for us to understand, you know, okay, well, we have a bearing fault on this particular machine. But it's those experts that are analyzing that data that provide that information so that someone can go act on it. And so, you know, not everyone has that capability, but today I would say that the solutions are smart enough now to provide that first pass analysis of the data. So they're measuring the vibration, they're providing the insights into the health of the bearings and other mechanical elements around the motor or pump or whatever it might be. And then they're notifying the maintenance teams that, hey, look, you know, you have a problem and it's a bearing fault. And then the maintenance teams are going to dig deeper, or the service provider is going to know that at this facility, we need to send out our team because we have a machine that has an alarm, or we have a machine that has a warning, and we need to make sure that that's you know, under control and that we know when to change it out. But it's making that information as easy to use and digestible as possible so that these teams don't necessarily have to be experts to extract the value. So ease of use is a big one, and that helps in the acceleration and the adoption of these technologies as well. The more complicated it is, the more difficult, the more resources or time or money has to be spent on training. And, there's a finite amount of time and resources available with many of these customers. So the easier we can make these technologies, the better, the faster, that they can take advantage of it. So there is a balance there between training and then also making it easier to use so customers can extract as much information from it as possible.
Thank you. Okay, let's move to Chris then and get your perspective on baby boomers UK and training, and perhaps ask in passing whether are there other special factors in the UK, such as emigration, loss of engineers to Europe and other places that's also playing a part.
No, absolutely, Andy. And there's a few things I'd like to add on there and agree with what Pete shared there. I mean, I'm kind of in the middle of the baby boomers and the new ones coming up. I'm that lost generation in the middle sort of thing that can see both sides of the coin. I grew up without mobile phones and things like that, but I learned to adopt them in my teenage years and things like that. So we get to see those changes in that. And some of the things there are, I can add to there with Pete, with the baby boomers and things like that, the skills gap, it's passing on that knowledge. But at the same time, you're passing on knowledge from people that have vast experience, but maybe have been working in maintenance in Industry 2, for example, that don't have that digital experience themselves. Whereas you have this younger generation that have, been brought up with a mobile device since the womb, for example, where they see things and they can collect things quite easily and adapt to those. And one of the key things I think to all of this, and with the introduction and evolution of maintenance 4, is change. It's culture change as such, and things like that. It's taking a lot of engineers that are out there at the moment out of their comfort zone, out of what they know and what they've been doing for many years. That's a key thing there. I mean, all of these technologies and platforms are there to make things easier and make a difference. And you speak to any engineer, the main goal of an engineer is to make their life easier. If they can do something without having to put as much effort into, they'll find the way to do that. So that change, it's through, from the person that makes the decision through to the person that holds the purse strings with the budgets. It's having everybody on board with that culture of looking at making those improvements and finding ways to make those gains. And another thing that I see in industry as well is, people will be happy, or industry will be happy to spend a lot of money on new technology and new investments in that way. But if you compare that to the budget that they would hold to then invest in their people, there's quite a difference. And I also think investing in their people is just as important as actually investing in these technologies. As we were saying there about, understanding the data that they're seeing, there is still a need for training. My experience as an electrical engineer on the tools for many years and an engineering trainer in the past, it's key to learn the fundamentals. And that's where we can help bridge those skills gaps, because the baby boomers of yesteryear would have learned all of the very finite principles behind what they do. Whereas the younger generation these days, the training's getting cut shorter to get them out because there isn't enough of them. The younger generation don't seem to be as interested in STEM technologies as such as we would have been in the past. It's more box on, box off when something's gone wrong instead of changing components. So learning those very fine, principles behind what's actually happening with their assets is quite key to understanding then when they look at a vibration or ultrasound trace as to actually, oh yes, I understand exactly what's going on. So it's those principles that are key as well.
Yeah, it's a very, very important point. I'm going to come to Daniel next, and then finally to Michael, because Michael will be leading the next session. So that's the reason. Nothing personal, Michael. Before I do that, just remind the audience to communicate with us in the chat or the Q&A. we've probably got a very wide age range, so maybe some youngsters might like to comment on what Chris has said about the fundamentals not being so well understood by our younger generation as they were in years gone by, which is an interesting point, and any technical questions that are coming to mind about the technologies that we've talked about and we'll talk about in more depth shortly. So Daniel, how's the baby boom situation in the Netherlands, and how do you cope with training issues there?
It's tricky for me to comment specifically on the Netherlands because whilst I'm based here nowadays, I'm from the UK. As you can probably tell from the accent, I don't sound very Dutch. Yeah, so I'm very much still involved with the UK side of things. I think to pick up on a couple of points that Chris and Pete mentioned. Pete mentioned about this kind of mindset change over the last 18 months since COVID has kind of been around, and I can kind of echo that sentiment in that, yeah, we almost saw that overnight in kind of a flip of mentality from people wanting kind of remote connections and remote data, in some cases being a complete no, to overnight when they couldn't reach site anymore being a absolutely yes, we need it now. And I think that has to be something that's going to be planned for going forwards, in that, yes, touch wood, there'll never be another COVID situation. But what happens if something happens where you can't reach your devices or you can't reach your site? I think now there has to be a continuity plan for that. Whereas before, I think this caught everyone semi by surprise. Maybe some of the large manufacturers had a plan for this type of situation, but for many small and medium-sized businesses, this completely caught them off guard, and they hadn't invested in the infrastructure or the technology before that. And yeah, I mean, literally, it was like a flip had switched overnight here at Ixon. In terms of some companies, we've been telling for years about the benefits of kind of remote connectivity and remote servicing, and it was always, oh yeah, we'll sort that another time, or that can wait 6 months. And yeah, overnight it was very much we need it now. So I think that's an interesting point that Pete raised about kind of that mindset change, and sort of connecting on to Chris's point again about the workforce. I think that the aging workforce is quite interesting because there's kind of benefits and negatives to both sides of this. And you're absolutely right in saying that a lot of knowledge is kind of harbored in engineers' minds. Some of the older generation, as we're kind of describing here, but it also presents an opportunity in that we're very much a data-driven society now. Data science is kind of part and parcel of what what people are learning and what people are interested in. It's all down to data, and at universities and stuff like that. Within computer science, data science is now being taught quite openly, and that presents quite an interesting opportunity for future engineers in that they can combine traditional engineering techniques with that data background to be able to provide a better rounded engineering experience where they have their expertise into both sides, and that's really exciting because I don't want to generalize, but I would say from experience, some of the older generation, they're not so interested in data-driven decisions, but more gut feel decisions perhaps. And I think that's quite exciting that is going to be more and more applicable going forwards.
We've had a couple of interesting, one simple question. Excuse me. Will I be able to view the Zoom later? Yes, absolutely. There's an on-demand version, so that's that. Question from Henry, which is, I think, quite pertinent at this point, which is, I believe that it's accurate that a lot of knowledge will be lost. However, there's also a huge amount of bad practices that will also be leaving the industry, which is a slap on the wrist for those of us who've passed retirement age, I guess. I personally have found the older generation have been educated in a very rigid way. Discussion I used to have with my father-in-law actually, and they're very, very good at following rules, but breaking out from the rules are a bit more of a struggle. And like Chris said, I'm kind of a little bit in the middle, I suppose. But I've you know, I've recruited a lot of youngsters both in engineering and in publishing, and I've found they don't have an understanding of those rules, but they have a huge amount of flexibility to learn in lots of different ways, and so you can pick up on what they're missing, in spite of the fact that they haven't been taught it in school and college, and therefore there's a huge amount of benefit in what young people have to offer, particularly in a fast-moving environment such as we have now, where things change on a, you know, almost an annual basis. Technology will be different, as Pete said at the outset. So that's my answer to that one, but it's time for Michael to get involved and maybe give his thoughts, and then we'll go into the second session, which is about factors accelerating the adoption of AI and industrial automation. Over to you, Michael.
Yeah, thanks, Andy. Yeah, I want to add something, briefly about the previous topic. It's the thing is, all the technology is already in place. I mean, what people already installed, they can do sort of maintenance 4.0, and I mean, technology is already in place. It already is all about the way we think. I mean, when we design a new system, we never think about the maintenance or the maintenance 4.0, and it's just we just have to change the way we're going to realize on and design the new installation, and we will get data, and people will be able to do quickly maintenance 4.0 more effectively. That's our opinion. About the AI adoption. Yeah, that's true. I mean, we mentioned the retirement, but there is a lot of different scenarios where people's skills are going out. So you have the Brexit. I mean, you mentioned it, the retirement, but also there is less attraction for industry by youngest people. They are more attracted by IT world than industry world, and that's also going to create a gap of skills and people on site for the maintenance, the application, the sites, or the production maintenance. Of course, the COVID also created a strange situation where the manager and the skilled people couldn't reach sites, and they couldn't help production to make their tool better or working. So some people has to do the maintenance by themselves without or remotely. Or yeah, it was a very strange situation, and yeah, I think these two or these three situations just creating a use case, a real use case for artificial intelligence needs now. So I don't think it's a real adoption, but it's a big interest now. They see the value, they see why they would need it, and they see the also where they could save money by using it. Even though I think artificial intelligence, for me, it's hard. It's a big word. I would say I prefer to call it artificial assistance than intelligence, because it's not a real intelligence going to take decision for you. It's more artificial assistant where the tool is going to provide you some scenarios. Okay, in this situation and this situation, I've been able to analyze that several years ago or a few months ago, and we react in this way. We got this results. Or yeah, we have also have these scenarios, which is it's very close to what we are living actually, and we react in this situation with this proposition, and we got this result. So it's good because you base your decision on scenarios proposition, but also on skills. You've been able to log, and so you keep the skills over the years. I mean, it can be 10 years for 15 years. The system will be able to track all these skills, and that's where I think it's a real value. But now, and I think that's where the industrial world is seeing the value, because they fill the gap we mentioned earlier, where people leaving to retirement just go out or leave the industry with their knowledge, and with this system we will be able to keep the knowledge inside the industry or the organization. So yeah, I think yeah, I think artificial intelligence it's a big it will be a big trend in our future industry for these reasons. Okay. And the good thing is with Industry 4.0, Industry 4.0 is preparing the field for this technology, because Industry 4.0 is generating a huge amount of data. And with the data, the deep learning technology and all this advanced technology will be able to grow up, and more data we're going to collect and generate and everything, better this system will be and more accurate they will be. And that's going to create scenarios more and more accurate, and people will be much more and more autonomous on the production line, and one needs more skilled people. And yeah, it's going to be a very interesting tool in the future. The other thing I see it's also the young generation. They used to use artificial intelligence by using internet all the time. As soon as they have a problem, they go to internet and they try to find a solution. And it's a new way to think. They don't work on their own and just, yeah, I learned that at school, or it was like this, somebody teach me, it was the only way to do it. No, now it's different. You go to this famous assistant, which is Google. I think it's the first one we use. And we try to find the solution, and it's exactly the same mechanic with artificial intelligence or assistants. So that, yeah, I think that's where we see the adoption. Now is not on site yet. I mean, we're gonna have to wait a few years before people install it on site.
Yeah, very, very interesting, Michael. How do you go about making a business case for adopting these new technologies in maybe an SME factory that might be managed by people of my age or slightly less that aren't too keen and familiar with the concept?
How you mean? Sorry, I didn't get the beginning.
How would you go about preparing a business case to justify the investment?
Oh yeah, you have to put all this information, because I mean you have to see a long term with to create the business case with that. So it's all about people. That the first thing. It's also about the memory. I mean, maintenance team is good just because of its memory. More they know exactly how the system works and how to repair it quickly. Better they are in their activity every day. I mean, maintenance is all about, of course, about diagnostic, but where they are good, it's about their memory. More they remember what happened the months before or the year before, and how the machine react when they did that or this action. Better they are. I mean, diagnostic it's rare at the end. It's more about how to react quickly on this situation. We already got. That's where they have their own value, or they have a big value. So, and if they reduce, the repairing time or the action time, if they reduce this time, they're going to be more efficient. So if they are more efficient, they're going to cost less, and they can also reduce the amount of people in the team. I think that's where we have to find the justification for a business case. Yeah.
Can I ask a question?
Yeah, please. Yeah.
So once you've actually deployed artificial intelligence, or a company's gone down that route, how do you actually instill trust with employees, because in the actual data? Because if you don't have the experience of artificial intelligence, and this is a huge leap, how do you instill the actual trust in the data so that you continue with artificial intelligence?
I think it's at the beginning you're gonna have to work. I mean, doing a double check. I think it's like a bit at the beginning of Google, where we had not a full confidence about what Google said us or proposed us. We always double check with a book. Now, I mean, our confidence is there, and we know which which website we are confident in, or where we can find this information or this information. And I think, yeah, at the beginning, people are gonna have to test it, evaluate it, see how this tool reacts, if the scenarios fit with what they think. So it's going to be a sort of a balance between the human experience and how the machine reacts, and more the confidence, the human confidence will come on the system more and more. They will work together more and more. And it's also the system going to grow year after year. More data you're going to put in, better it will be. It's like, if you remember the translation systems at the beginning, they were horrible. You couldn't, it was very strange. I use a lot, to translate from English to French, and trust me, it was very strange. And now it's much better, and it's also because we put more and more data and more information, and they are capable of analyzing more situation or translation mechanisms. And I think it's going to be the same. And the interesting thing is artificial intelligence system will be completely different from one side to another side. That's going to be, and each one gonna have to be trained, and each team gonna have to use to work with it and adapt to his reaction, and that's going to be an interesting situation. So that's where I think the maintenance team gonna have to adapt. So when you're when you're going to to hire somebody new, you're gonna have to learn about it and say, okay, in this situation I get this answer, but it's not always a good one. Probably the second answer is better. That's how I see it.
Thank you, Michael. That's a great answer.
Andy, maybe
yeah, I was going to come around in a circle to ask for other input on that. Yeah, can I say how nice it is to have a colleague asking some intelligent questions as well? So, Pete, you come in, and then Daniel.
Yeah, I just wanted to touch on a few key points there. I think Michael and even Aaron touched on, and I think they're related. It's the business case, justification that's critical. That to us is sometimes as complicated as the technologies in some cases. If that's not figured out, the technology is going to be difficult to adopt. So then how do you do that? The trust feeds into this as well. And I'll explain that in a little bit more detail. We work with a lot of service providers, maintenance providers today, and the opportunity for them to deliver maintenance solutions or deliver maintenance to their customers is assisted by a lot of these AI technologies, the automated predictive maintenance solutions that are out there. And the opportunity for them is to be able to deliver maintenance more efficiently. So can they do it in a just-in-time fashion so that their teams are spending their time wisely in areas that makes the most sense, as opposed to just sending out a team that's always making their rounds, and there may or may not be a problem. Now they have visibility into where those problems are with AI and with these automated predictive maintenance solutions, and they know exactly where their team should be spending time. And then they have everything planned and understood in terms of what needs to happen. And then that also gives them kind of the visibility into the operations in a more real-time fashion, without having to have presence on site. And then in addition to that, it's creating new ways of how they can improve their overall business by maybe reducing some of the operating expenses that are associated with it. And so all of these opportunities that help justify the adoption, they do have to be kind of vetted, with these trusted maintenance providers, and they do have to have some level of confidence in their ability to deliver what they say they can deliver, and that's why I think that we don't look at maintenance 4.0 or industry 4.0 as kind of the replacement of all these activities that we're talking about today in terms of maintenance, that's always going to be needed. You know, somebody's going to be needed to maintain machines and equipment and understand how it's running. And these technologies are there to make it better. These maintenance teams are trusted, right? They've been doing this for decades. They have a tremendous amount of experience, and the customers rely on them to make sure that their operations are running efficiently. So if you can help work with them and build that trust through demonstrating the technologies, how they perform next to their existing capabilities, and then how they augment those capabilities, then that helps to justify that adoption and the business case for those teams, and then they reap a lot of reward in terms of how they can optimize those businesses in terms of the just-in-time maintenance and other services they can provide. So I think there's a combination there that they kind of tie hand in hand with, you know, with each other to make that effective. So that's how we see it. I think those are very good considerations.
Yeah, it's a good answer, and it kind of implies that there are two different audiences that really have got to be convinced. One is the maintenance engineer, which is an engineering problem, yeah. And the other is the business owners or the directors who very often are unlikely to be engineers. So you've got to kind of tone down the engineering capabilities and look at it purely in perhaps finance and investment terms, and two very different audiences. They can be the same, can't they, in small companies? Yeah. But perhaps in larger companies they're not. Let me throw all those curveballs at Daniel and see what he makes of it.
Yeah, just picking up from what Pete said, really. I wonder what your thoughts are on a situation where I'm going to use the word future because we could be talking 5 years, 10 years. You know, we're meant to already be flying around on hoverboards by now. If you were looking at tomorrow's world 20 years ago, but yeah, in the future, do you see a point where perhaps there isn't a requirement for a maintenance engineer anymore in the near future? In a maintenance engineer that actually sits on site and is an employee to a factory or to a manufacturer, in the respect that if OEMs continue to technologies and integrating ways that they can A, connect remotely, B, access data and share that data, the question is not why, but do you see a point where the maintenance is fully provided by the OEM rather than someone that sits on site at a factory? Because surely from a warranty maintenance perspective, you want the OEM to, they're the absolute expert on that machine. They're the ones that built the machine. They're the ones that are the experts in that particular part. And if you envision a factory that's made up of 100 different machines, all from different manufacturers with their own specialities, maybe there's a point in the future where, you know, connectivity is so good that maintenance provided directly from the OEM and not by on-site engineers, which let's call them a jack of all trades, but they don't know any individual machine at a deeper level. So I just wondered what you thought on that kind of scenario and whether it's likely from your experience.
Yeah, you certainly can't. Certainly something that has to be considered. I think you can't rule that out. I would say that you know, the advantage that, you know, some of the maintenance teams and facilities teams bring to the table, though, is that while they may not be the expert on that particular asset, they do understand how that asset works best within the environment that it resides in. So it's not just understanding the asset; it's understanding the asset and how it's you know, part of that much larger operations. And does the OEM bring that level of understanding, you know, to that environment? You know, the processes that are specific to the products that are being run, you know, are part of that as well. So there's a lot of variables in there that have to be considered. but you're right. I think that is certainly an opportunity that we can see, this going, years down the road. But I think there's still a lot of value in localized understanding of the process, the operations, and how everything is working together, that are going to be part of that delivery of maintenance in the future, and making sure that these operations are fully optimized. And so I think it's a balance. I think I couldn't tell you if I wish I could tell you for sure, but it's just something that we have to think about right now.
I think it's a very interesting idea, and it kind of came up. I mentioned in the green room before we started about a series of seminars we're doing on safety, and we were talking there about the issue of having, linking different machines together and what effect that has on the safety environment. And I guess this is kind of a similar thing where you might need somebody on site because the maintenance implications of a system that involves several different machines is subtly different to the maintenance requirements on a single machine. So you may well go in the direction that Daniel's suggested, but in many cases it might not be the entire answer, it seemed to me. Anybody else want to comment on that before we move on?
Yeah, I think the maintenance is going to be much more granular than it is for the moment, where we base all the confidence or the maintenance task on one team on site, or the main task on the one team, one site. I think in the future we're gonna have different maintenance levels with different. I mean, it's going to be much more complex. The teams, you're gonna have some very expert teams, but mainly managed by the OEMs, and gonna have some local team and some for the advanced. I mean, the artificial intelligence, of course. I mean, gonna have to be also maintained and configure. I mean, I think the maintenance is going to be much more complex than it is for the moment, actually. Yeah. The organization.
Thank you. Okay, Chris, we're heading naturally, I think, towards your session, in that we're talking about systems now as well and multiple data sources. So may I ask you then to now talk on the process of collating data from multiple sources and what the implications are for that?
Yeah, absolutely. And just to pick up on some of the things there, I mean, I love the way that Michael expressed the way AI is it can be seen as a automated assistant, because it's there to provide that data to the engineer, and it's that engineer then that can use that data to make a decision and decide on the next courses of action and things like that. I think that's a key thing with this. And talking about, we've talked there about confidence in these technologies and things like that. A lot of the technologies that these systems are integrating are not new technologies. They have been around for a long time. People understand those technologies. It's just now a different way that it's being presented. Whereas an engineer might have been using a handheld device to go along and collect that data, then using that data to upload to a system and then make the decisions. It's now removing that collection process from a manual perspective to a remote one, which is it's no difference. So hopefully industry will see that, and when people are explaining the differences with these systems, they can understand that. And then looking at how you can convince people to as a business case, there's always that divide, operations over maintenance. Every time there's something there, operations will take priority, removing maintenance windows and things like that. And as an engineering department, if you lose your maintenance window, how are you going to know the health of that asset? And that's where maintenance 4.0 is going to be helping them with catching those things. But it's about looking at a lot of industry at the moment. They operate on a just-in-time logistics scale. And if we haven't got those things in time, then production can be halted, could be scaled back, and that could incur a lot of costs to the manufacturer at that time as well. So it's about, using these technologies to give us that advanced warning to improve our lead time to failure, so that we can plan as an engineering department, plan to see the changes in the condition of the health of an asset, so that they can look at maintenance windows. They can then discuss with operations for that downtime at a suitable period of time to make sure that those problems don't impact on actual production itself. Looking at it from my sort of perspective, looking at the world of reliability-centered maintenance, it's not a new thing. It's been around for decades. It's just evolving over time as we go through this transformation. Vibration collection, ultrasound inspections, thermal imaging, oil analysis, they've all been around for a long time. And there's not really one technology that's going to look or be able to identify all potential failure modes of an asset. So, an engineer cannot rely on one specific technology that's going to be the savior of all potential problems. It's where it's important here to look at FAMICA's failure mode effect criticality analysis, looking at how you can, put your assets into a criticality list, looking at the ones that are going to cause you more pain if they are to fail unscheduled. That's going to cause a lot of downtime, a lot of problems. But then they've also got to understand, how can that asset fail? In what ways will that fail? And then looking at those ways it might fail is understanding what technology is best to identify those at an earliest point. Now, traditionally, a lot of these technologies would have been handheld based. An engineer would have had to go along, collect data, present that into the software that comes with that system, and then try and look at that and make a judgment. They may be using multiple technologies, ultrasound, vibration, thermal imaging, and they might all have traditionally their own softwares that are not integrated. So an inspector could be collecting all of this data, then having to try and find a way of putting it all together to understand the bigger picture. And that's where a lot of the transformation in maintenance 4.0, tying in those technologies into a centralized location, can then help, like an artificial assistant, providing all of those key parameters to help them understand that. And then going back to some of the questions we were talking there about, will maintenance 4.0, bring the end to having engineers on site? I think there's still some key areas where engineers are always going to be required. From my experience as an engineer in the past, there's nothing really that can beat being actually on site at that asset, that you can, see, smell, hear things that maybe AI might not be able to give to you. And that's also alongside with experience from those engineers too. So it's about, grouping together your assets, looking at the criticality, and having a combination of, remote sensing technology that can feed back to you from anywhere, looking at cloud-based platforms and things like that, that can give you your, key insights into those areas, but also, utilizing the manpower that you do have more efficiently. Looking at still handheld data collecting techniques still is important. I've had some examples recently where there was a site and it was a specific asset looking at a fan, and there were two departments that were looking after different parts of this asset. And the site reported an issue with dropping pressure from this fan. The one department looked at the motor data that they were getting remotely and said, well, the motor's working fine. And the other department that were looking after the fan, the remote information they had, well, there's no alarms on the fan. And as we then took a handheld device to go out and have a look at the asset, we come to find the belt had come off. The belt had come off the motor. It wasn't driving the fan. And they all said, oh, if we hadn't come up and had a look at this, we would still be scratching our heads trying to work out what's going on. So there's a bit of a misconception with some engineers as well out there that maintenance 4.0 and remoting everything out is going to be the savior. whereas the old traditional methods are still just as important to utilize with that. We've seen it with ultrasound, for example, starting back in the early 70s with handheld devices, just listening and taking readings from that point there, to now going full autonomous ability as well with cloud-based solutions. You know, the evolution is really picking up now, and we're seeing that with you know, the likes of COVID, you know, having alternate shifts that have to be on site at different times, reduced manpower on site so that you're spread thin on the ground. It's really key to be able to see that ramp up and look at different ways of making life easier, in my opinion. And I always like to, you know, when it comes to a business case, discuss, especially with large production companies, is what is the cost of 1 hour's unscheduled downtime? And we all know that if you have a highly critical asset that fails unsuspectedly, it's not going to be down for 1 hour. It could be down for several hours, days, even weeks, depending on the size of the asset. And that can be extremely costly. And in some instances, depending on the criticality and the size of the asset, the payback, if they could avoid just one failure in that year, could pay for the full system entirely. And that's where you get together the different departments, the finance, the operations, the engineers, and get them to understand those implications if that was to fail. That way they can see that bigger picture and bring everybody on board like a chain. Because if there's a chink in that chain, then it's going to fail. There's something that's going to fail in that process. And that's key, in my opinion. Along with that, you know, training, it's still important training to understand these technologies. There are a lot of overlaps. And I think it's very important to have a diverse approach when it comes to predictive maintenance, is utilizing the best from multiple sources to give you that justification. Because if you say to operations, we need to take that line down because we've got a problem, then you're going to need some pretty strong evidence to be able to justify your reasoning behind that. So that's very key too. That's where the way I see the changes, and looking at different types of technologies there. It's bringing it into a holistic view, in my opinion. Whereas it's key to have that change, and it's great to have that data all collated in one area. But let's not forget the basic principles, and let's keep to those strong traditional approaches as well as a good combination. It's about strategy.
Yeah, I think you've highlighted two really kind of interesting critical things there. Is in setting up a system, you know, you do need a lot of engineering expertise in order to make judgments about the right way to measure and interpret the data that's coming out. And the second word that you used, which I very much took on board, was payback, and how to calculate it, which you know, comes right back, of course, to the business case, as you said. So we're not really losing. We've got to have expert engineers to set these things up, and we also need to listen to the guys on the ground who know how their individual machines work and behave, I think.
Yeah, this is another thing, Andy, as well, that I see another misconception with industry as well, is that people see the evolution of maintenance 4.0 and think that just by implementing this, that's going to improve their reliability. My personal view is that by implementing these technologies, it's going to improve their availability, the availability of their assets. Now, with that key data and the engineers on site with that experience, if we have any sort of failures with those critical assets, they can perform things like root cause analysis, which then, with that information, with the data collected in the platforms, we can then provide that back to the designer, the OEM, that can take that data and change the design of the asset, maybe to make it more improve the maintainability, or actually remove the actual design flaw that caused that failure in the first place. It's only at that point there that we're actually improving the reliability, because reliability is built into the asset from the start at the design stage. And that's a big misconception I see in the industry out there as well.
Maybe that's a theme that we could quickly do a circular on, is how do you design maintenance into a machine rather than you know, retrospectively have to worry about it. Chris, do you want to quickly comment if you've got anything further to say on that? Then I'll go to Michael.
I mean, when it comes to design, it's looking at, you know, access, maintainability. How can we get into these key areas? Again, just looking at failure modes. What is more likely to fail on this asset, and how easy is it to access? How easy is it to, you know, if there is a failure, to change that out and get it back running again? That's the key thing, I think, there.
Michael, do you want to comment on that, the issue of designing maintenance into a system?
That's a complex question. I think you're right. Yeah, the concept. I mean, if you finish the cycle, it's the best to do. It's going to be always complex to do, but more data you will be able to share with the OEM better. The next system will be, but the system you have actually won't change. So it's a big value for the OEM. Is it a big value for the maintenance? That's another question. But yeah, it's tough. I mean, it's tough how to collect all this data and share them. I don't have a real opinion about it.
Yeah, I guess the more data that's coming into a system, as you said, the better system 2.0 is going to be, because it can take account.
It's still the case. I mean, it's always been the case. I mean, I remember it's already the case. I mean, people are sharing with their OEM machine builder or their machine builder, oh yeah, it doesn't work here. Or they call every week because they have this problem, or every week. So the OEM, if it's not too stupid, it will change his machine for the next generation. So it's still, I mean, it will stay like this forever. The thing is going to be, I think the data we're going to share is going to be more accurate and more valuable, and it will be easier to adapt quicker. So we're just going to gain time, but the process at the end is still the same. So that's is always going to be for the second version.
Okay. Quickly, Pete, do you want to add anything to that? And then we'll come to Daniel for the easy wins session.
Yeah, I'll a few comments on that. I think you know, there is a need to understand, you know, the failure modes, the mechanisms that are causing some of these problems. You know, we have our technology, excuse me, that we use is AI based. And it does provide the ability to identify, you know, anomalies and you know, behavioral or possible behavioral problems that are outside the optimal operation of equipment. But it is up to, you know, the users of the assets, whether it's the operators, whether it's the maintenance teams, you know, for them to understand, you know, what are my failure mechanisms, where are my biggest problems. And how do we measure the assets, you know, whether it's vibration, whether it's, you know, voltage, current, pressure, what's the sensing modality needed to understand how to capture that? And then, you know, can we, you know, there's a lot of talk about data. Michael mentioned, you know, the more data, the more valuable this becomes. But I think it's taking it to the next level is, you know, all right, we have a lot of data. We understand our faults. How do we take that and convert that into insights so that we can take action? And so if we know the failure mechanisms, we know the optimal optimized operation of the asset itself, and we can identify when anomalies or non-optimal behavior is occurring. Then you can use that AI to say, look, my machine has a loose belt. We've seen this before. We can tag this anomaly as a loose belt issue, and we can take action. And now you have all that data. You have contextual information as well. You know, what's the environmental, you know, operating conditions of the asset or the system that we're looking at, And when you combine all of that, it allows you to feed it back into the process at various stages. Maybe process optimization, and maybe maintenance optimization. There might be different ways to use it, and depending on how those customers want to use that data, it's going to feed into different points within this automation stack up or pyramid. The SCADA, the MES systems, the condition monitoring systems. So yeah, I think we are collecting better data. But it's also combining that understanding of the assets to make sense of that data so that we know what to do with it as well. That's a critical next step here, because we do run the risk of being inundated with data and then not knowing what to do with all of it, and then how do we get the benefit of all this new information we're collecting. So yeah, we do have to make that leap for our customers as well.
Thank you. Well, with that concern, I'll pass to Daniel now to lead our discussion on easy wins. We've covered a lot of issues this morning, including payback and new technologies, improving technologies. Anyone who wants to ask questions about specific problems or comments, please keep them coming in the chat. We welcome them. Over to you, Daniel, to give us the positive send-off that we need.
Thanks, Andy. Yeah, so from the outset, I kind of say that my focus in this kind of discussion is around OEMs, because that is, that's the market that we work in, and that's what we know best. So yeah, everything I'm kind of mentioning is coming from a OEM machine builder kind of perspective, perhaps system integration too. So I guess it kind of links nicely into a couple of the themes that we've talked about today already in different parts of the discussions about the relationship between the OEM and the sort of factory owner, in terms of whose responsibility is it for providing data back to, you said about the factory owner providing data back to the OEM so that they can improve their machine. But is that their responsibility? Should the OEM themselves not be the ones that are at the forefront of understanding their own machines and what's going wrong and improving those? So there's certain things we can look at in terms of that. So I guess the one I'd like to start with, and sorry for the kind of directness of this one, in that our company is involved in remote access technologies, utilizing remote VPN for machine builders mainly. And well, that's a very, very easy win for an OEM. Now, it also has benefits for the end user, of course, because it's kind of a two-way thing. You're buying from a machine builder, and that's generally going to a factory owner or into industry. So remote access technology is nothing new. Again, like we've said about a couple of things in this call today, this isn't new technology. This has been around for 10 years, maybe longer, way before I was even involved in this type of stuff. So remote access is, yeah, a very, very easy win. And any large machine builder, OEM machine builder, should be or is now utilizing that technology. Because, again, coming back to payback periods, etc., you're looking at one site visit being saved to pay back for that kind of technology. It's not expensive. And if you're not utilizing that, from both sides, it's kind of an argument. So we hear sometimes machine builders say, well, our customers don't ask us for remote access, so we don't install it. But then on the flip side, we also hear that that as a factory owner, you're kind of reluctant to have this type of technology. And it comes down to the question of why. So from a factory owner side, would you not want to be able to receive support quicker? Would you not want to be able to get your machine back online faster? Because as we mentioned here, an hour's downtime, a day's downtime can cost you thousands, hundreds of thousands of pounds, euros, etc. And yeah, from a machine building side, would you not rather have your staff not out on the road, not on planes, not traveling, expenses, etc., when they can simply sit in your office and maybe create a remote connection to deal with that? So don't get me wrong, there's always going to be situations where someone physically needs to go to site, and that is always going to be, there's always going to be a need for that in some way, shape or form. But we've had scenarios, and we have a few case studies that I'll link in the chat afterwards, but scenarios like a machine builder from the UK sending an engineer to site in the US. He walks into site, changes 3 lines of code on the PLC, gets back in the car and flies home. And that's ludicrous in today's day and age. It's a waste of time for the company. It's a waste of money. It's emissions. It's not very environmentally friendly. So that's a very easy win. Remote connectivity is an easy win. And if you're kind of reluctant to that change from a factory owner side, again, some of the things we hear like, oh yeah, we don't trust the cloud. Okay, well, do you use mobile banking on your phone? Yeah, we do. Okay, so you do trust the cloud then. So there's very different kind of thoughts into industry and personal use. And yes, there are differences, but it's more kind of reluctance to change and learning and understanding why things are secure. And it's not like by adding a device, you're completely opening your factory up to the internet. It just doesn't work like that. So that's a very, very easy win. So that's one to kind of box off. When it comes to data, I think a common misconception from machine builders that we hear is that they need to kind of plaster their machines with different sensors to be able to get data. And again, I think linking back to what Chris has said, that's generally not the case. A lot of this technology already exists. A lot of important stuff that you might want to monitor from a machine building perspective is already available in the PLC or on the drive. It's just actually utilizing that in a better way. And by plastering your machine in with sensors, you actually kind of get to a point where you've got so many sensors, and all these sensors actually have sort of mean time between failure rates, that you end up spending more time fixing the sensors and upgrading them than you do actually utilizing the data. So yeah, you don't need to be doing that. A lot of this data is already available in the PLC, and it can be really simple. It can be things like, how many cycles has a machine done? How many hours has it run for? And as a machine builder, if you know that after 1,000 hours, or maybe 10,000 hours, or whatever that is, you expect certain parts to fail, well, wouldn't it be great if you could ring up a customer when you were kind of 90% of the way through there to say to them, hey, your machine's at 90% of its kind of rated allowance for this, since it's been built, or whatever that may be, and you can offer them a service. And that kind of then builds into a recurring revenue. You have a better, closer contact with your customer. Yeah, there's kind of benefits for everyone there. And from an end user perspective, you've got the peace of mind knowing that your OEM has actually got an eye on the machine, monitoring it for you, and that is that it's a proactive cycle, not just waiting for a fault to happen and then send an engineer, or then call up and be upset that you've got downtime. It's actually a collaborative approach to that. So I think that's also an easy win in types of data that you can actually achieve from machines that are relatively modern, as long as they're sort of utilizing PLCs from the last 5, even 10 years at times, Modbus TCP, OPC UA, Siemens S7, that type of stuff that's in, protocols that are in there. You can generate a lot of data that's really beneficial for both parties, and that sharing can also work both ways. That data can also provide you with a USP over your competitors. So if you imagine that you can sell a machine that comes with an analytics package and a warranty and a kind of preventative maintenance, well, you have to be careful what you say about preventative maintenance here, because there's only so much you can do with the data. You still need to have the expertise for that. But imagine being able to offer that compared to a competitor who just says, yeah, here's your machine and off you go. I know who I'd rather buy a machine from, someone that's actually utilizing data, looking at insights, wants to collaborate, wants to make their machines better, and wants to give you the best experience to make sure that you effectively make the most money or make the most product or whatever that is. Yeah, that's a really good USP over companies that may have not yet incorporated that type of technology. So I think there's various things. There's two there for starters. Yeah, there's many more, but I think time-wise, we're looking a bit short. So Andy, I don't know if you've got any sort of questions on the back of that one.
No, that's a really good summary. Aaron, please.
I thought you disappeared, Andy. Sorry, I was just.
Oh, sorry. Okay. Well, let's do one thing before we finish, and it's kind of how we came in a way, that we've got new technologies coming on board. So I thought it might be just a little bit of fun if we ask each of you to nominate a technology that you think is going to be revolutionary, maybe in 5 or 10 years' time, and we'll quickly go around the panel to ask them. And before we do that, so you have a little bit of thinking time, just like to thank all of our registrants for attending this morning, to say that we have a wonderful panel here who are very keen to answer your questions offline as well as online this morning. So don't be shy in putting your requests for further consultancy to them. They're part of our Talking Industry family, so once you're part of that, there's no escape, I'm afraid. And we will also open up our LinkedIn facility in case anyone wants to continue any discussions openly after the event. So that's your thinking time. So Daniel, which technology would you identify as being the revolutionary one for 10 years' time?
I think combined with kind of everything we've talked about today, I think the topic, or I don't know how the product looks in an end form, but actual predictive maintenance when it's up and running and fully fledged, and where machines can actually start to take their own decisions. I think we're not that far away from that when you've got tools like Power BI and Tableau and big tools for big data that can take data from hundreds of devices and actually kind of compare them to each other. And it might be that they need to start slowing drives down after 80% of their life cycle, or whatever that is, to make things smoother and to kind of offset downtime. I think, that kind of predictive maintenance, when machines can actually make their own kind of smart decisions, maybe with the approval of a human, who knows? But when they can actually do that, I think that has really big benefits for the general uptime of industry going forwards. So that's one that I'm kind of most excited about, I'd say.
Excellent. Machines making their own decisions. Michael, what would you pick?
Yeah, if you talk about machine, yes, I mean, in my opinion, they already take their own decisions, the machine itself. But I think, the maintenance and the system going to communicate more together, and they will be able to take decision in function of what the other machine is going to, how the other machine is going to react on the situation. And I think it's more what's going to happen in the future. That's how I see it. Artificial intelligence, I think it's going to take, if we come back to my topic, I think it's going to take a lot of time. But this interaction and adaptation will come quickly.
Lovely. So that's machine interaction, how they interact with each other.
Yeah.
Chris, what would you pick?
So I wouldn't necessarily go down the lines of what particular technology will be the big growth in the future. I think it's the strategy that's going to change. That's going to be the big growth. Moving, and it's already the wheels are already in motion, moving from a preventative time-based maintenance program to a full predictive maintenance program, and that will utilize handheld devices and multiple technologies and centralize that as a platform itself. I think because of what we've seen in the current climate, that's where industry are going to move, and it's going to be the big thing, the smart factory, the gigafactory. It's going to be that maintenance strategy that's going to be the big change.
So strategy rather than technology per se, smart factories. Lovely.
A combination.
Okay. Aaron, do you want to have a vote on this? You're a smart factory person.
I would say that the increase in the mega factory I think that will be the gigafactory. That will be the future.
Excellent. And Pete, we leave it with you.
Yeah, I really like Chris's suggestion there on the smart factory. You know, and I would also add to, you know, what we see the AI being critical as well, and AI being a big enabler of that smart factory, because it can be applied across a broad range of assets and enable that type of insight that feeds into that smart factory. So understanding, you know, what we do with all this data, what this data means to that smart factory, how do we optimize it? You know, the AI is going to be a key piece of that.
Excellent. Okay, so that's optimizing data is the key one there, and use of artificial intelligence. That's great. Well, we must all meet up in 5 years' time and see how correct we were. That really runs us out of time. So I'd just like to thank all of our panelists for their contributions, which were all absolutely excellent. So thank you for that. And thank you for all our attendees for your time. And we hope you found it useful. And as I said, we're here for further advice and consultancy as you wish in many different ways. So thank you very much, everybody, for your time. And we look forward to seeing you next time. Thank you.
Thanks, everybody.
Thanks, everybody.
Thank you.